One of our presenters a little bit further down the line in this particular session is looking to make a big announcement before lunch today. And with any luck, we'll be the first people to hear it. So I'm really looking forward to hearing that, because that could have a big influence on whether or not you invest in said company before the end of today at 4 o'clock. That's what I love about these, is and that's why you're here, is to talk with our presenters and talk with our companies and get some information, some first-hand information. For those of you who are listening online, welcome to you. So you don't have that same ability, but still it's great to be able to listen in on these presentations. And what our presenters do too, when you see the slides that go up, there's phone numbers there, contact numbers there. They've put them there for a reason, because they are happy for you to contact them personally. So please don't think, oh, so-and-so is from this big company, I will never get through to them directly. You will get through to them directly. Stewie has made sure of that. It's part of his mantra. Right. Mr. Trevor Beardsmore, would you like to come and join us, please, sir? Trevor is the manager, New Energy Systems Geological Survey of Western Australia. He's kicking off our second session here today, analysing WA's position as a new world metal powerhouse. He's worked for the Geological Survey of WA for the last 10.5 years, mostly as manager of the Mineral Geoscience branch, leading a team studying the mineral systems of WA. I could go on forever, but I've been listening to this man talk about what he wants to talk about, and he's very passionate, so I'm hopping off and I'm giving him his full 15 minutes. Will you please make him welcome?
Well, thank you, Chrissy, and thank you for coming along and listening to me speak on Western Australia and as a new world metal powerhouse. Now, I am very passionate about this, and I'm not sure whether I'm going to fully get through everything I would like to say, but let's get cracking. So my role really at the moment, if I can get it to work, here we go, is to firstly place everything into some sort of context from our point of view. So Western Australia is transitioning to a new energy economy. We want that economy to remain resilient and to grow and diversify. We also want it to be powered by renewable energy. And we also have committed, like many other jurisdictions, to be net zero greenhouse gas emitting by 2050. Big calls, big asks. So WA also has the value of being able to provide what we believe is a reliable and ethical supply of the raw battery and critical materials that people are going to need for this new energy transition. And we don't want to just be the quarry to the world. We also want to be part of the downstream processing and component manufacturing, and hopefully even building our own batteries and so on and so forth. So the little documents you see there are some of the policy documents that the government has brought out in the last 3 or 4 years. I won't bore you with those. If those of you are interested in seeing them, you can get into that on the relevant websites. So WA is, as I say, well placed. We have a very large share of production of minerals globally, and you'll see there, again, I'm not going to bore you with actual figures, but we are a major player globally, and in some cases we are the preeminent supplier of some of these materials. Lithium, for instance, we're ranked first. Iron ore, of course, we're very dependent on that, but we're usually in the top 10 for many other critical minerals and other commodities. And just on the point of critical minerals, I'll just point to those those elements that are highlighted in red. These are those sorts of elements that many of the companies who are presenting today are looking for, because these are the commodities that will drive that new energy transition. They're required for the components in those technologies, wind generators, batteries, and so forth that we will need. And WA is no slouch in providing those even now, but also having the potential to provide even more in the future. So just, you will have heard this many times perhaps, but just what is a critical mineral? It's really something that is of national economic importance to whichever jurisdiction is making a list of them. It's required for the ongoing health and well-being of their manufacturing industries. It's also a commodity that might have a supply security risk. There may only be one supplier, only a few, and we've all seen examples where that can have issues for obtaining the materials you need for your economy, and there may be no substitutes for that particular mineral. Now, as I said, each country has its own list. We've got the USA, EU, and Japan there. They have their own lists of what they regard as being critical minerals for their jurisdictions. We are well placed to supply that. And so I've got WA there as well, indicating the minerals that we actually know we have or are currently mining or are in the position to begin mining. You'll see that there's a lot of correspondence between ourselves as a supplier, potential supplier in some cases, and the jurisdictions that require those minerals. And the little periodic table there just summarises that. So you can work through that at your leisure. If you want the presentation, just send me a... what's going on? All right. Now, we don't just, as I say, want to be a quarry. We also want to diversify our role in that new world metal value chain. So you will have heard, some of you, that we are actually moving in that way. Many companies are now either operating or constructing downstream processing plants to produce the chemicals from those raw materials that other jurisdictions may need for manufacturing their high-tech componentry or other things. There are a number of planned ones as well, and they cover a range of the critical minerals there, so lithium and nickel, vanadium, rare earths, and we are also stepping a bit further along that value chain, if you like, by taking some of those chemicals or planning to take some of those chemicals and building some of those precursor components for the downstream value chain. And I guess the ultimate ambition is that we will become producers of batteries ourselves. So what does that mean for the Geological Survey, which is what I'm actually here to talk about? How does the Geological Survey fit into this aspiration for Western Australia? Well, our primary role is to provide trusted, pre-competitive geological and resource information so that anyone who comes to the state can know what we have and how much we have. The reason we do that is because we wish to encourage mineral exploration, and we do that by reducing the technical risk for companies who are exploring for these minerals by providing them with geological information which allows them to make better decisions or cleverer decisions about where they should be exploring. And from doing that, we hope then to foster resource discovery and development. So ultimately, our goal is, as an arm of government, to promote Western Australia's resource sector as a world-class investment destination. And anyone who reads the Fraser survey of mining companies will be aware that last year WA scored the top position once again for that. So we must be doing something right, at least I think we are. How do we fund this? We do that through our exploration incentive scheme. $12.5 million a year we get to be putting towards gathering new geological information and processing that. That comes, of course, from a component of rents on tenements and such. There are four main streams, which are just listed there: regional geoscience data, prospectivity mapping, exploration through cover, and drilling and exploration. Most of the exploration companies here will be well familiar with the co-funded drilling program. Half of the $12.5 million every year goes towards funding or helping co-fund significant drilling programs that might be looking in new areas or investigating new concepts. So over the 12 odd years that it's been running, we've spent about we've offered $115 million to over 1,200 projects from companies. And we think it's doing the right sort of thing. We've engaged a couple of independent consultancy evaluations of the value of the EIS. And the latest one suggests that for every $1 spent by the EIS, we get $31 back. Now, we do these we open up for applications for the EIS every 6 months. The round 26 has just recently closed, so too late if you wanted to get into that one for companies. But the next round 27, will open for applications in early February next year. Now, we do so much. We're an organisation that's been around for 135 years, longer than most stock exchanges, and certainly longer than many companies who are on stock exchanges. So we have an enormous database, and we're constantly collecting new data. So all I can really do now is give you a taste of what we do. So one of the, I guess, newest acquisitions we have is what we call our Airborne Electromagnetic survey data. We've been doing that in collaboration with Geoscience Australia. This essentially maps the electrical structure of the upper few hundred metres of the crust, and that can reflect the presence of the right sorts of minerals or the structures within the crust that might control where those minerals are. Now, we released the last bit of this. We've been collecting it since 2019. The last part that we've released has been in the Murchison region, the western part of what we call the Yilgarn Craton. We released that in March. In the same month, almost simultaneously with releasing it, 3 companies came up with targets that they generated from this data. Even though it's very broad-spaced regional statewide data, 20-kilometre line spacing, it still apparently had value to these particular companies for defining targets that they should be exploring for. If you want this data, it's available on our website, and I'll keep reiterating that. Another example is what we're calling our WA array. We're going to measure the seismic activity that passes through the state and use that to map the architecture of deeper parts of the crust and uppermost part of the mantle, again, because that may help us to locate regions of mineral energy prospectivity, identify the sorts of structures that might contain these. It also has a much more pragmatic use for local government and for state government in helping us to define where there are areas of activity. There have been quite a few relatively small but still noticeable earthquakes throughout the southwestern part of Western Australia over the last few years. This will help us define where these are most likely to occur and therefore also help with land use planning decisions. We're spending $30 million over 10 years. This is a special extra grant that we have, plus money from EIS to do this. The map just shows the segments that we're going to be doing this over the 10 years, 160 to 170 little seismometers or little seismic detectors placed in the areas. We're starting in the southwest and we'll gradually move across the rest of the state. And we'll be doing this at 40-kilometre spacing, which we believe will give us good resolution for companies to use and for ourselves. Geoscience Australia is deploying this sort of technology nationwide, and they will be looking at co-deploying some of their work at the same time, at least in the first couple of years. Petrophysics, any geophysicist in industry will be bemoaning the fact that we don't have enough information about the physical properties of the rocks to allow very good modelling of the structure of the crust based on magnetics or gravity. So we started a pilot project where we're collecting some of that information from our drill cores and releasing that. We're doing it in 2 tranches. One tranche of that data has come out now. The next tranche is just being completed now, and you'll soon see that data. That will hopefully allow geophysicists in our own organisation and in companies to translate the regional geophysical data into realistic geological models, so get better decisions about exploration targets. We also like to add value to the data we already have, and this is almost old news in talking about the Accelerated Geoscience Program, which we did in financial year 2021 when no one was allowed to travel anywhere. But we actually thought, well, let's look at our own data and see if we can use it and provide extra information and knowledge from that. We did so. We came up with perhaps about 1,000 new derivative geoscience layers looking at different aspects that we thought might help with exploring for and discovering new mineral systems. Okay, so 4 broad areas there. You can look at the abstracts if you like on our ebook shop. You can get the data from these areas here, GeoView from our Data and Software Centre, USBs from the main counter if you wish. Here are some of the output just to give you, again, a taste. So mineral occurrences, Mindex. We're now able to provide you with layers that show where individual commodities are. So not just a big splash of colour, as you can see on that left-hand diagram there. Geochemistry is the big one. For years, companies have been wanting to get into the WAMEX, what we call our Western Australian Mineral Exploration Geochemistry database. We've now extracted it all, created a single database, which we've harmonised so that you can actually start using the data. So all this stuff here, all that there is significantly expanded our geochemical data and can now be used for targeting. And so you can get information like fertility indicators of mineralisation, and here's just a couple of examples here. All of these are described in the abstract volume for the Accelerated Geoscience Program. And you can also use our WIROX database. We have hundreds of thousands of observations over 130 years by our geologists doing their field mapping. You can now query that and pull out useful information that might be indicative of mineralisation, host rocks for mineralisation or mineralisation itself. And so, again, these are just maps that you can get out of those. And we have many, many other statewide geophysical and geochemical and isotope layers. And we've also reinterpreted that gnarly area in the southwest of the Yilgarn there. It's been a big sea of pink for a long time. we've now reinterpreted the geology there to give you a better idea of the sorts of rocks that might be there, which will help explorers in their quest for minerals. How do you get the data? Well, you go to our numerous portals. So the Data and Software Centre is where you download the data. You can also view it in our GeoView application, which looks a lot like what I'm calling the Mineral Systems Atlas here. The Mineral Systems Atlas is essentially a subset of GeoView, which just provides you with specific information. Come to us and I'll tell you more about it. Some new text and other search tools. So you can actually search the WAMEX data now and download that data, that geochemical data. Again, it's freely available. Go to these places and you can get that information you want. So really a lightning tour of WA and the geoscience, the Geological Survey. I urge you to come to booth 15 where Sarah and myself and Sabrina as well are waiting to answer your questions. And consider subscribing to our various social media sites and to our newsletters, and consider coming along to Open Day in November and learning in more detail what we've been up to. So thank you for your attention. I wish I could have spoken more.
You've taken every bit. Well done, Trevor. Brilliant. I think you covered it nicely. All right, we're just going to push straight through. Martin Stein, can you come and join us, please, sir? Martin is the CFO from Altech Chemicals. Altech Chemicals is advancing its game-changing silicon anodes TM electric vehicle battery materials product. Lucky I'm not saying this after we've had drinks this afternoon. That's quite a lot to get in. Yeah. Would you please welcome Altech's new CFO, Martin Stein, as he discusses this issue further. Thank you.
An Australian company has finally cracked the silicon code and produced lithium-ion batteries with 30% higher energy capacity. The company has utilized its game-changing alumina coating technology that successfully incorporates silicon into the graphite anode of lithium-ion batteries. The result is a 30% higher energy battery with improved cyclability or battery life. This next-generation lithium-ion battery technology is destined for the electric vehicle industry. Tesla has announced that the required step change to increase lithium-ion battery energy density and reduce costs is more silicon in battery anodes. For this to be achieved, high energy capacity silicon needs to be introduced into anode chemistry. Silicon has 10 times the energy capacity compared to graphite. In the words of Elon Musk, this is the most promising anode material. However, metallurgical silicon is unable to be used in commercial lithium-ion batteries today due to two major technological barriers. Silicon expands up to 300% in volume during battery operation, causing swelling, fracturing, and battery failure. The second challenge is that silicon deactivates up to 50% of the lithium ions in a battery. Called first cycle loss, lithium ions are rendered inactive by the silicon, immediately reducing battery performance and life. Industry has been in a race to crack the silicon code. But Australia appears to be at the forefront of the race. This innovative Australian company's game-changing technology delivers alumina-coated silicon particles, which resolves both the swelling and first cycle loss capacity problems. A 30% higher energy capacity battery will mean significant cost benefits to the battery and electric vehicle industry around the world. Phase 2 of research and development work will see the company strive beyond the 30% energy increase. The company has already commenced a pre-feasibility study for a construction of a 10,000 tonne per annum battery materials plant in Saxony, Germany, to service the burgeoning European lithium-ion battery market. And that's the lithium-ion battery update.
Good morning, everyone. Thanks for allowing me the opportunity today to present to you all Altech Chemicals Limited and the technology that we're developing at the moment. So just to give you an idea of how a lithium-ion battery works, I'm having a bit of trouble here with playing. Okay, here we go. So just to give you an idea of how a lithium-ion battery works, the lithium on the charging of the battery goes from the cathode side to the anode side, and on discharging, the lithium will return from the anode side to the cathode side. But what a lot of people don't realize is that on the first charge, 8 to 10% of the lithium sticks to the anode side, the graphite side, and it's rendered inactive and it plays no further part in the lithium-ion battery. So that's a bit of a problem, losing that much capacity on the first cycle. So what happens is it forms an SEI layer on the first charge. And the lithium ions formed in the SEI layer don't play any future part in the performance of the battery. So this is called the first cycle capacity loss. During the operation of the battery, the SEI layer breaks down and exposes fresh sites, so then more lithium is absorbed and lost in the performance of the battery. During the operation, hydrofluoric ions, which are in the electrolytes, when there's water around, break down the SEI layer and more lithium is absorbed in the battery. So there is a degradation of lithium as you go on. And there's a fair bit of research that goes around that says that HPA, or high purity alumina coating, can solve this problem, solve this first cycle loss. And HPA coating is what our business is involved with. So this is one piece of research that shows a coated graphite battery versus an uncoated graphite battery. After 200 cycles, you can see the coated graphite material has 10% more energy capacity. Now, this slide talks about thermal runaway. So here's a test that shows on the left-hand side non-coated graphite batteries. And they've done a nail penetration test, and you can see that the battery virtually catches the light from the thermal runaway. Temperature source is about 600 degrees. On the right-hand side is a test performed with a pouch battery on coated graphite material. You can see the battery is still intact and the temperature rises to only about 90 or 100 degrees. So there are three methods that the industry uses to coat. There's the atomic layer deposition, or the vapor method. There's the solid method, and there's what we do at Altech, which is the liquid method. So we have patented technology to put a very fine layer of alumina around graphite and silicon. It's a 2 nanometer layer and it prevents the SEI layer from forming. The beauty of this is that lithium can go through and it doesn't stop the performance of the battery. So I mentioned about the hydrofluoric ions. There is a lot of research that shows that the alumina layer absorbs the hydrofluoric ions and turns it into an inert material, so it doesn't impact on the future performance of the battery. So there's quite a lot of benefits from this alumina coating. And if we look at this slide, it shows under microscope on the left-hand side what Altech is doing with the alumina coating. It's a very thin, regular, continuous layer of high purity alumina. This is our patented technology. On the right is what is happening in the industry at the moment. It's very irregular coating. So you can see the difference with what we're doing compared to the industry. We believe our process is a cheaper process. It's easier to commercialize, and we use high purity alumina, which has less contamination, and we can adjust the coating of the material. And because of the low operating temperatures, it's cheaper to produce. And what we are aiming for is something like this. This is the typical performance of a battery. If we can extend the life of the battery by leaving more lithium ions in the operation, we're going to get an extension of battery life. So if we talk about silicon, at Tesla's recent battery day, they've identified silicon as the most promising anode material there is on the market. It has 10 times the energy capacity of graphite. So there are 10 times more sites that the lithium can stick to on silicon than there is on graphite. But if it's such a great material, Why isn't it being used in commercial batteries today? Well, there's essentially three problems. The first one is that silicon expands 300%. In volume, in lithiation, it cracks and it swells. The second problem is the first cycle loss. So instead of graphite losing 8 to 10% of the lithium on the first cycle charge, silicon will lose about 50%. Big problem. And the third one is high fade. If you have less lithium ions, you're going to have less life of the battery. So the industry's been trying to resolve this problem. As I mentioned, there is an expansion of the silicon particle by 300% in volume, and it actually fractures. Now, what happens is when you have a silicon atom in the anode compartment and it fractures, you get delamination. So the material comes away from the copper collecting and you get swelling in the battery. So let's have a look at the potential of silicon. It takes 6 graphite atoms to hold 1 lithium atom. It only takes 1 lithium atom to hold, 1 silicon atom to hold 4 lithium atoms. So you can see the potential of getting silicon into the anode of a battery. And if we look at it in its bar chart, you can have a look at pure graphite in an anode. It provides about 372 milliamp hours per gram. But if you can get 10%, 20%, or 30% silicon into that battery, you're getting much higher energy capacity for the battery. And we'll have a look at the commercial impacts on that on a Tesla Model 3. So the Tesla Model 3 at the moment's got 0% silicon. It gets about 423 kilometers to a battery. If you can get 10% silicon into that battery, you're going to get 680 kilometers. 20% silicon is going to get 940 kilometers, and 30% silicon is going to get nearly 1,200 kilometers. So getting silicon into the battery can extend the capacity of the battery. You can get extra range. Or the alternative is that car manufacturers will downsize their battery size, downsize the weight, and make it a cheaper product. So we've done all of our test work in our R&D facility in Kewdale in Perth. It's done under the guidance of a well-respected, very smart individual within our organisation called Dr. Jingwan Liu. And through our testing of 12 months development, we've come up with a 30% increase in lithium battery capacity by using this silicon product. And we announced that in about November last year, and the market reacted very well to those testing results. So basically, in a nutshell, what our business does is it takes graphite particles, it takes silicon particles, combines it together, and then coats it with a very thin nano layer of high purity alumina. And we call this product Solumina anodes. And we're in the process at the moment of building a pilot plant in Germany. We're in the process of building a pilot plant. We've finished off a pre-feasibility study for a full-scale 10,000 tonne per annum plant to be built in Saxony, Germany, on land that Altech's purchased. The pilot plant is being constructed right next door in a leased warehouse to this land that we own. The pre-feasibility study has come up with some very pleasing economics, including a net present value of $507 million US, an internal rate of return of 40%, payback period of 3.1 years, and what we think is most pleasing, it's a very cheap construction cost of 95 million US, which we think will be funded by a mixture of equity and also grants that are being made available in this region by the German government. We've got supply agreements with 2 leading European suppliers of graphite and carbon. This is the pilot plant area where we're building the pilot plant. Now we're going to use that pilot plant to produce 120 kilograms per day of the Solumina anodes product, which will be then distributed to potential end users, car makers and the like. And we are hopeful that we'll be able to get an offtake agreement for the product from that. 3D visual illustration of the pilot plant. Now I'm running out of time here, so I don't think I'll have time to show you the whole footage. So I'll skip through to that. 40 seconds remaining, so I'll wrap it up. Why are we focused on Europe? Well, we think Europe is the next phase of lithium-ion battery technology. The car manufacturers over there are all moving towards lithium electric vehicles. You can see the amount that they're spending and when they're spending it by. So there's fantastic opportunities there for a company to get into the lithium-ion battery space. And this is a final illustration that shows the demand from Europe for graphite and the gigawatt factories that they're building. 600 gigawatt hour factories are being built. So there's going to be demand for about 400,000 tons of graphite, and we hope to get into that space. Thank you very much.
Well done, Martin. There is a lot to get through with these presentations. You handled it well. Now, the global shift into the electrification of society, growth in EV production, renewable energy. There is a Perth-based exploration company, RareX, who are aiming to, there's no stairs on that side, so well done, to become a near-term producer of neodymium. Don't come up with any claim there for any injury you might have done trying to get on stage, okay? So the focus of RareX is on developing the Cummins Range project. Now that's southwest, about 135k southwest of Halls Creek, up in the East Kimberley, East Kimberley region, isn't it? East Kimberley. Yep. So presenting for us, the gentleman who's just leapt up onto stage is the founder and MD, Jeremy Robinson. Would you please make him very welcome?
Thanks very much for that introduction, Chrissy, and thanks to Stewie and the team for hosting us here. I think this is our second conference at this event. As was mentioned, Cummins Range is the hope of RareX. We've been aggressively drilling it all year, well, for the last 3 years actually, and this year we've been doing a lot of test work and building the team out into a very interesting rare earth space, which is developing just as quickly as a lithium space. So I'll talk you through the company. I'll talk you through the thematics around rare earths. And yes, I'll point to our economics, which we'll talk about at the end of this presentation. So the company, obviously an ASX listed company. We've been trading for about 3 years now. We've got built a very good board around this very good project. John Young, the chairman, Cameron Henry brings a lot of processing expertise with Primero there. We've built out the development team. We've got a GM projects. We're just in the process of appointing a metallurgy manager at the moment as well. And we're very happy with the team we've got there. 10 million in cash at the end of last quarter. We've been aggressively spending. We're probably down to about 6 or 7 at the moment, but we've got enough to get on and do what we need to do through the back half of this year. Very supportive shareholder base. And a relatively modest EV at the moment. So we think we've got a lot of upside left in this story and share price for shareholders. So the value proposition behind RareX, we're tapping into the EV thematics. I think we're all here for that thematic. Rare earths are very, very useful in this, in the EV, in wind turbines, in everything everywhere there's a lithium battery, everywhere there's an electric motor, you've probably got rare earths in high-end rare earth permanent magnet motors. So we think it's a very good space to be in. We're focused on rare earths. Neodymium, praseodymium are the ones that we're getting behind. And what we've been doing this year is growing the size of our resource. We think by some stage next year, we should be in the top 3 or 4 by size rare earth deposits in Australia, which should put us in pretty good stead. We're a traditional hard rock deposit. We're not chasing the clays. We're sticking to our knitting here. We're going to follow in the footsteps of Linus and people that have built rare earth mines before. So hard rock rare earth deposit. The asset, as mentioned by Chrissy in the introduction, we are just to the southwest of Halls Creek. We are in the East Kimberley. It's a very beautiful place. I very much like travelling up there, but we're very focused on what we're building at the moment. We're just off the Tanami track, which is in the process of being sealed. I've been talking about sealing it for 15 years and they're finally getting on with it next year. So by the time we're in production in 3 or 4 years, there will be a sealed road to within 50 k's of our project, which is very, very advantageous for us. The geology of the project, as I mentioned, it's a hard rock project. It's a carbonatite. There are 2 mineralised carbonatites in Australia. in terms of the intrusive style, which we have. Dreadnought and Hastings have carbonatite affiliations, but in terms of the true carbonatites that poke up from the centre of the earth, it is Mount Weld Linus and it is Cummins Range with RareX. We're in the process of permitting our project. We put in our mining lease application earlier this year, in negotiations with the traditional owners at the moment, and our exploration never stops. Well, it does stop when it rains in the wet season, but we've been out there since late March, early April, and we'll be there till Christmas this year as well. Quick exploration update in terms of what we've been doing this year. This is a plan view on top of the dike. We've been drilling out our high-grade rare earth zone. We have a resource there currently of 18 million tonnes. We published an exploration target start of this year at those ranges there. So we're targeting, a resource towards 50 million tonnes at close to 2% some stage next year. We won't quite get there with the drilling this year, but we'll definitely get there next year. We've also had some success expanding a phosphate zone, which exists to the north. I've got the pointer here. This is our rare earth zone here. We also get phosphate there, but we're getting some really, really interesting high-grade phosphate zones out here as well. And you might ask why we're chasing phosphate. Phosphate often comes with rare earths. These carbonatites do host both rare earths and phosphates around the world. Phosphates have come into vogue, into focus at the moment, as a lot of it comes out of Russia and the price has gone through the roof. So we're very much having a look at that as well. Oh, here I go. Talking about phosphate again. This is the northern zone. This is in the mineral apatite. It also contains appreciable rare earths. We think we can make, this being an igneous type phosphate, not a sedimentary phosphate, we think we can make a very high grade, probably close to 40% phosphate concentrate out of this stuff. And will be very useful and very, very marketable around the world. You can see from the photos at the bottom, it's very coarse grained, so we expect the processing to be very, very easy. So onto the NdPr rare earth thematic. This is what we're doing. We're into NdPr, neodymium, praseodymium. The primary uses for these in terms of their magnetic properties are in electric vehicles and in wind turbines. The greatest growth is very definitely electric vehicles. The one people aren't focusing on is offshore wind turbines. There is extreme growth in that as well. They're very high efficiency magnets. Why are we convinced of the thematic here? Why are we convinced of the growth in rare earths? It's all about EVs and the switch from internal combustion engines to EVs. You hear a lot about lithium. That's very much what we've all got used to hearing about over the next couple of years, but everywhere there's a lithium battery, there's probably a rare earth permanent magnet nearby, if not 2 or 3 of them. In your Teslas, you can get up to 2 or 3 motors containing rare earths. So the whole world is going this way. There's a huge spend on this, and we expect it to continue. And further to that, look, governments around the world are legislating this into existence. This is not something we're talking about anymore. Governments are very much making us do this. The Inflation Reduction Act out of the US, which I haven't mentioned here, but I think some talkers today will talk to. This has been further compounding this because they can no longer source their rare earths from China to put into their cars, into their electric motors. So I just don't know where it's all going to come from at this point in time. Obviously, you've got Linus there. They're the only ones, and there's a few of us coming up behind. So this is going to be a really exciting space for us to grow into. And this shows you just exactly what needs to happen over the next decade. We're probably talking about a project the size of Linus coming on stream every 2 years. I can't see a project the size of Linus coming on in the next 5 years, to be honest. We've got a Luca talking about a project that's half the size of Linus. There is Arafura's, there's us, there's Hastings, there's Dreadnought with their fantastic discovery as well. But these things were all 3 to 5 years away. So this price is going to be well supported, for the foreseeable future. I'll just give a little talk on phosphate. Price has gone through the roof in the past 6 months since our friends in Russia invaded Ukraine. What has happened here, up to about $320 a tonne seaborne out of Morocco, where most of it comes from. That price doesn't look like coming down anytime soon. It looks like a spike on that, but don't be surprised if it stays there. Most people can produce it at around 100. We'll get a premium for our product. We very much believe this will become part of the RareX story. And I should also mention about phosphate. It's not just a fertilizer story. Phosphate is useful in LFP batteries, lithium iron phosphate. These are the batteries that will be increasingly used. You don't have to rely on cobalt and nickel, which are largely conflict minerals. These are better batteries for the world to use in a sustainable fashion. So watch this space for phosphate. The team, as I mentioned, we've been building out the team. When we started three years ago, it was just myself, geologists, metallurgists, process engineers, consultants that have worked in rare earths. These are the people you need to build these projects, and we're in the process of building that team out at the moment. We have a strong ESG commitment at RareX. I've been working with PwC to establish our framework, and we'll start reporting against that this year. So we do take these things seriously, and we're committed to the communities in which we operate. Very important in the Kimberley. Study work, we choose to work with industry-leading consultants. At the moment, we're in a trading halt pending the release of our scoping study, which has been at least a year of hard work, led by James Durrant, who's our GM of projects, and supported by some very good consultants. That scoping study is based solely on our 2021 resource, so all the drill results you've seen put out this year and coming into next year will be in addition to this. The economics around that are many multiples of our current market cap. We will be a significant producer of rare earths and NdPr. We will try and tap into the Lake Argyle hydro plant, so we will have a green angle to our story. We will be the only hydro-powered rare earth refinery in the world. We will put out an appreciable amount of phosphate as well, and this is just the start for the size of our project. As we grow this resource, we will grow the scale of the downstream infrastructure as well. So the investment proposition, why should you have a look at us? It's the right time for rare earths. Prices are high. Prices will continue to stay high. We're about 88. NdPr has been up to 175. I see some leading forecasters forecasting 200, and don't be surprised if it does something silly next year. We think rare earths are the next lithium, if not already. We think we're the right company. We've got a relatively modest EV. You can get involved with us now and enjoy the ride. We will grow the size of this project. We will have a 50 million tonne deposit at some stage in the next few years, which will put us in a rare echelon in Australia, and a team to deliver. We're building that team out. The team we've got now is very good as well. So that's it very quickly. I'm not known for my long presentations, but I'll be at the booth for the rest of the day and probably for some of the evening as well. So please come by and have a chat. Thank you.
Well done, Jeremy. Great presentation. Very, very informative. And we will were the words that he was using, Thomas, weren't they? We will. Right. Dr. Mark Cooksey, I love this guy. He's got a voracious interest in engineering and tech, and he's always good value to listen to. So I know you're going to enjoy this presentation. He's presenting on behalf of ABX Group, who are creating new sources and technologies for strategic minerals and chemicals by discovering and developing niche deposits and developing novel chemical engineering processes, which is where this guy comes in. Dr. Mark Cooksey is the CEO. Please make him very welcome.
Thank you for the introduction. As we know, Australia relies on imports of many minerals and chemicals, and we would suffer enormously if those supplies were cut off for any reason. So my background's different from a lot of people that you hear presenting at these conferences. I'm an engineer, not a geologist. Rio Tinto, CSIRO. I've been involved in process development for 20 years. And so, as Chrissy said, I love these opportunities. And if there's one thing I want you to take away from my presentation today, is that ABX Group is judiciously investing in good opportunities to create new supplies of strategic minerals and chemicals. That's the standard disclaimer that you can memorize. And just an overview of ABX Group. Over this calendar year, we've had 3 nice increases in share price, always correlated with our rare earth results, including one just early this week. So I encourage you to go and read that. And ABX Group, I'm mainly going to talk about rare earths today, but we're not just rare earths. So rare earths is number one we're going to talk about. The second one is aluminium fluoride, which is a chemical needed for aluminium smelting. And we're developing a process to produce that. And our third area of activity is bauxite exploration and mining, which is where we began 10 years ago. I'm not going to talk about that today, but it's still an active area of our business. So firstly, rare earths. I'm following on from Jeremy's presentation. I'll try and match it up. So as he said, and as we all know, rare earth demand is growing a lot. One of the interesting things is that, when you mine rare earths, there are a certain ratio in the ground. There's lots of applications for rare earths, which the mix is different. We need more of one and less of another. And those ratios between the supply and demand, will never match. They can't match when there's 15 or 16 of them. So it means the ones that are in deficit, extremely high prices, $1,000 a kilogram. The ones that are in surplus are basically worth almost nothing. And as Jeremy said, the demand that's most interesting and growing is the permanent magnets. In actual fact, even I was surprised by this, permanent magnets represent 90% of the value of the rare earth market today. And it's really the four elements listed on the right. So despite the fact that there's lots of them mined for lots of applications, almost all of the value is in this, and it's growing because of the EV and the wind turbines. So then you get, well, where do we find them? So as most rare earths produced today are produced from hard rock deposits like Lynas. You can find occasionally good grades of those, and although the processing can be relatively expensive, it can be a good project. It turns out, interestingly, that of the heavy rare earths, which tend to be the more valuable ones, most of them come from China, and most of them don't come from hard rock deposits. They come from what is called these ionic adsorption clay. So it's a clay deposit where rare earth elements have adhered to clay particles. And the West, I think, has been a bit slow to realize this, that over 20 years, China's developed a way to extract these rare earths. Although the grades are lower, the processing cost is lower, so it can still be attractive. And so I guess it's become, we've more aware of it here now, and a lot of people like us are looking for these ionic clays. And it's worth, I added this slide last night. I think we're having this conversation so many times, it's worth really thinking about, what does clay mean? And what we're hearing now is a lot of people talking about clay-hosted rare earths. So this graph shows on the vertical axis is grade, and on the right, I've called it how mineralized is it. So a really good hard rock deposit, like Lynas say, is in that top right? So the grade's high, although it's all trapped up in minerals, relatively expensive to process, but it's attractive, right? Because the grade's high enough. The ionic clay is at the other end of the scale, sort of bottom left. The grade's lower, but because it's loosely attached to these clay particles, the processing cost is lower. That's what makes the ionic clays a viable alternative. Not necessarily better than a good hard rock deposit, just different and equally attractive in its own way. We hear the term clay hosted a lot. Now, clay hosted does not mean ionic adsorption clay. Clay hosted means you've got clay and you've got rare earths, but the rare earth there could still be in a mineral. Now, if it's in a mineral, maybe the processing won't be that easy. So my view is that clay hosted, the actual processing cost of clay hosted, we don't really know unless you do the metallurgy. It could be really good, or it could be quite expensive. So that's something that all of us need to remember. We're still all learning because all this knowledge is basically held in China. So ABX, what are we doing? So we are, well, definitely the first company to find rare earths in Tasmania. We're looking in Tasmania because we historically had bauxite there, and we had some theories that what led to the bauxite could lead to the rare earths. And what it looks like from our metallurgy work is that we do have this true ionic adsorption clay. So we got work done by ANSTO, who are the most knowledgeable in this area. They use the conditions that are quite benign, and we got pretty good recoveries from some of our rare earth samples. Other ones, you apply those benign conditions and you get very low extraction, 10%. Or you might get a good extraction, but you have to apply aggressive conditions. Our ones, we get good extractions with what effectively is easier processing. And it has the other advantages of the ionic clays, which is relatively shallow depth and very low radioactive elements. And so our plan is to, one of the other advantages of the ionic clay is because they're shallower depth, simpler processing, hopefully, is to establish the processing is lower cost and shorter time. So our plan would be to establish a mine where we can extract these ionic clay absorbed rare earths, do this relatively simple concentration to make a concentrate, which then in theory can be sold to other parties that have the separation plants that are equally applied to whether the feed came from a hard rock or an ionic clay. We had a major winter drilling campaign from April through to August. We've released most of those results. A lot of them came out early this week. We've got a bit more to release. We are planning to do our maiden resource estimate by the end of the year. And there's some more drilling planned and, as I keep saying, more metallurgy planned before the end of the year. The drilling and the assaying and the metallurgy are all equally important. You can't leave any of them out. So that's the rare earth story. I said at the beginning, ABX is not just rare earths. Another opportunity we've identified is aluminium fluoride. So now take your mining filter off. This is not mining. This is metal production. So Australia is a significant producer of aluminium metal. Still, we're number 6 in the world. We're number 1 or 2 in bauxite and alumina, but we still make a lot of metal. And aluminium fluoride is a chemical you need to add to that process to keep it stable. If you don't have it, if our supplies were cut off within a couple of weeks, you'd be thinking about, seriously, we have to close the smelter. We just cannot operate. And that's a $5 billion industry in Australia. Australia is the largest aluminium producing region in the world. It doesn't make its own aluminium fluoride. So we import it all, of course, mostly from China, a little bit from elsewhere, as you can see on the map. And the material aluminium fluoride is relatively expensive. It's over $1,000 US, and that's because fluorine is expensive. You really get fluorine from fluorspar. Funnily enough, Australia is one of the few things we don't mine is fluorspar. So we have a situation where we want to make aluminium fluoride here, but we don't really have much fluorspar and fluorine's very expensive. What are we going to do? Well, it turns out that the aluminium smelters are now producing a material. Well, they've always produced this material, but it's only recently become a waste problem. And getting to the point where they've got no outlet for it. It is 50% fluorine. It's the obvious thing to say as well. We need this aluminium fluoride, which has a lot of fluorine in it. The same industry is spitting out a waste that has got lots of fluorine in it. Can we marry the two? And that's what we've done. So we created a subsidiary, Alcor, to develop this process. And we take the waste from the aluminium smelting, and then it's a chemical engineering process involving acid and temperature to be able to turn that waste back into hydrogen fluoride and then aluminium fluoride. So it's really just a perfect example of a circular economy. We can make a valuable material at lower cost because we're using a waste, and we deliver the environmental benefit of recycling a waste, and we're doing it by supplying a critical chemical that currently we don't make. It's like, I've never seen that sort of story line up that well in my previous experience. And our plan, so we have done most of the laboratory work we need to do. That's at our facility on the central coast of New South Wales. We are about to commence building a pilot plant, which will be in the same location. It'll process 20 kilograms an hour of this waste material. And 20 kilograms an hour is a pretty serious installation. It's like a quarter of the size of this room. You really need to know what you're doing. When you look then to the ideal endpoint, we think the right size for a plant in Australia, and we're planning for Bell Bay in Tasmania, is 20,000 tonnes a year. To go from that pilot plant to that 20,000 tonnes a year is a scale-up factor of 150. That's too big. You're taking a big punt if you're prepared to make that jump. So we've decided we're going to first build a small commercial plant. So that's the box 3 there, at the same location in Bell Bay. So that will be profitable on an operating cost basis. It'll effectively take the bath from all the bath from the Bell Bay smelter and turn it back into aluminium fluoride that they can use. Now, obviously, the capital cost of that per tonne is relatively high. It's a very small plant, but we just over the last few months have received a $7.5 million grant from the federal government, Modern Manufacturing Initiative, which covers half the cost of that plant. And we're also in close discussions with the aluminium companies about how can they help us expedite the development of this process. I mean, I have people around the world calling me saying, Mark, we have this bath problem. We know you're working on it. When are you, can you take our bath now? I say, no, not quite yet, but as fast as I can. And so to sum up, as I said, ABX judiciously investing in creating new sources and technologies for the supply of critical minerals and chemicals. We'd love you to invest to help make us more secure from have our own supply and not rely on imports. But thank you very much.
Thanks, Dr. Cooksey. What turned you from CSIRO back into the commercial world? How did they lure you across?
In Rio Tinto, I was the technical guy. In CSIRO, I was the commercial guy. So I'm always at that interface between industry and R&D. And so this role is sort of similar. So it's just similar work, but obviously a different environment. And now I get to call the shots, which is pleasant.
Yeah, well done. Okay. Go and have a chat with him because he is a great individual to have a listen to. Do you people, by the time I got out of here during the morning tea break, there was nothing left. I think 2 strawberries and maybe some green melon. That's all there was left. So I've just tucked into my Cooper and Partners chocolate. So remember that they're up there, and also that bottle of Grange as you go around today. Krakatoa Resources is next up on stage. They're an emerging future metals exploration company with recent discoveries at its Mount Clare project here in WA. To tell us about the company and the opportunity, we've let this guy in with a little special clearance from him, because not only is he from Victoria, he also supports Geelong. I know.
Premiers 2022.
Yeah. Would you welcome Mark Major, everyone, please?
Thanks, everyone. Thanks for the opportunity to speak. Look, it's a pleasure to be here. I want to take you through basically Krakatoa, what we've got going on and where we are, and obviously sticking with the rare earth theme, and again, the ionic clay or the clay-hosted rare earth theme specifically. But I want you to make sure that you do take out that, Krakatoa isn't just a rare earth company. We've actually got 3 strings to our bow, and hopefully, if I get enough time today, we'll be able to show you that and prove it to you. So, typical disclaimer. Why Krakatoa? I guess this is pretty much usually one of the slides we throw in at the end, but I'll put it at the front for a specific reason, just to actually highlight what we are about. We focusing on rare earth metals, obviously elements, and obviously specialty metals as well. And right now, we've also got nickel PGE targets, which we're looking to drill before the end of the year. So look, we've got strong foundations. We've got the metals, we believe, in the ground, ready to go. We've got that growth potential, which obviously as investors, that's what we're all looking for. And we're located in Australia, tier 1 areas, obviously emerging mineral camps. And our strategy is focused. We are doing systematic, but yet very aggressive exploration. We are spending a lot of money in the ground, as we do as geologists, and I thank the board for being able to do that. And look, all our projects are 100% owned too. So there's not many companies out there that can sort of say that. So as a corporate overview, we trade on the Australian Stock Exchange as KTA. We've got 345 million shares on issue, about 4.2 million in the banks, a little bit less. That was at the last quarter. And look, we've got a very low EV comparative to peers, let's say, at the moment. If you look at this, we had a major discovery earlier in this year, and obviously that took our share price right up and gave us a much bigger market cap. As everything in the junior space has happened, it's all dropped off quite low. So look, there's your investment opportunity right there, peoples. Executive team. Look, I'll let you guys go on the website and have a look at this because there is a few slides to get through. But that's the team that's behind these companies, and we're going very well. As for the projects, okay, 6 projects in all. 2 of them I'll be talking to you about today. Mount Clair is obviously one of our focuses. We've identified clay-hosted ionic rare earths in this area. We've also been very fortunate also to identify some basement conductors, which we believe are very prominent to be nickel copper PGE sulfides. And King Tamba, just down the road, obviously that's a rubidium lithium, it's a pegmatite swarm, it's an LCT pegmatite. Over in New South Wales, we've got other systems. We've got an intrusive related gold system. We've also noticed some clay-hosted ionic rare earths in some of the granites that we have there, as well as tungsten and tin. And then we've got Belgravia, it's copper gold porphyry system, but I won't be talking about those ones. I'm just going to focus on what we've got near term, what we're focusing on right now. So everybody knows where we are. It's an electronic revolution. We're all moving in that direction. We know what we need. The minerals are set in stone. So this is just pretty much a rebating of what everybody else has been telling us all day. So obviously critical metals, where we look at the US department, this is quite an old slide, this one. We know there's neodymium, dysprosium, terbium. They're all up there. All the rare earths that we're looking for are in there. So again, just another bit of, you've probably seen this about 10 times today, so I won't drag on it, but like light rare earths, heavy rare earths. The good thing about this is, the market is there, the deficit's there, it's going to open up. Now, rare earths, obviously, as we've been explaining, and as Mark said from ABX, rare earths, especially the clay-hosted stuff, has been pretty much dominated by China. All the tech, all the information, all the IP is in China. Hasn't really escaped from there. So the rest of the world is playing catch up, and they're playing a 50-year catch up. And it's like anything in the world, as soon as you start to get that appetite for it and there's a demand for it, and especially now as they're becoming critical and special, we're actually going to see this industry really flourish, and actually a lot more of these things actually coming. So what is that? How does that all fit, I guess, into Krakatoa? What do we got? This one here just takes you through a bit of an idea of where we sit as a company, what projects we've sort of got. Now, Mount Clair, okay, we've got our rare earths, we've got our nickel opportunities, copper. We've also got pegmatites out there, which we know, which we've got to go and get sampled. The next one is, it's labelled there, Dalgaranga. It's actually called King Tamba now. Everyone was getting confused with the gold mine, so we renamed it. Now, that one there, sitting there, we've got some basically titanium, tantalum, zirconium, rubidium. There's a lot of things in that, as well as lithium. Okay, so discovery to definition. These are the share price catalysts, and this is what probably 90% of you guys sitting in this room, and girls are sitting in this room, are actually looking for. Throughout the last few years, we've been able to define our resource drilling over a tower project, which we just discovered these clay-hosted rare earths. We've started our initial metallurgical work, and obviously that is going to be ongoing, and that is one of the key factors with any clay-hosted rare earth deposit. By the end of, I'm probably predicting this, probably next quarter, we'll have our maiden resource out on these rare earths. We're also be undertaking probably more metallurgical studies, trying to crack those codes. And then obviously we've got a lot of upside in our area as well. On the flip side of that, looking at the sulfides, we've been fortunate to identify some basement conductors, which I'll get to, which is one of the major aspects, I think, and the big kicker for the company going forward. I could be up here next year touting the same thing as what Chalice has. That's what I hope. King Tamba. Again, that's an LCT or lithium tantalum rubidium project that we've got. We've drilled that out recently. We've had some news release put out on that, some of the results coming back from our drilling, and now we've got maiden resource coming out very, very soon. Okay, following that, we'll have obviously some metallurgical test work, and then we'll be looking into scoping studies. So that's what that looks like in a timeline. It's very convoluted, looks very busy. It is, because it is a busy time for us. Yeah, so look, we've got a lot of drilling going on. Right now, heritage surveys are happening in the next few weeks, which will allow us then to start drilling some of these sulfides that we've identified. Targets, sorry. 2 resources are going to be out before the end of the year. So, Mount Clair. Now I can slow down a bit. Mount Clair. What we've discovered here, and I'll take you back probably about 2 years when I first started with Krakatoa. We'd had all this ground up there, and there was like a lot of hope and a lot of ideas that were going around. Now, this is an area that hasn't been very well explored, but when it was initially explored, it was explored for different minerals. So we've been able to take that and identify that we do have clay-hosted regolith occurrences in the area. We proved that earlier this year. We then came in, re-drilled that, and we've drilled out a nice resource base for it. We've also been able to identify these large-scale sulfide targets. They're drill ready. We do know there is heavy mineral sands in the area. We do know we've got zircon, rutile, ilmenite, and obviously monazite. Monazite is the backbones of the rare earth, what we have up there. So we do understand that the mineral component that we do have is all coming from monazite, which is obviously one of the well-known minerals. Obviously, there's also a lot of additional rare earth regolith that we have in the area. Now, so the opportunity here is really for us, again, to identify some hard rock sources of this. We've seen what's been happening around the area, and we understand these, and we do have a lot of targets here. It's just about getting manpower and getting out there. You know, we've got over 2,300 square kilometres that we're exploring at the moment. So it's quite an extensive area, and I've been around and gone over there with quad bikes, and that's the only way you can really get around these areas. Okay, so the Tower Prospect. We put out an exploration target on this after we drilled this initially. This was the discovery we made back in April. You can see those red, actually the green dots up on the slide here to your right. Now, those ones there are the initial drill holes that we did. Now, we drilled those based on the tracks that we could get access in with the drill rig. So they were just haphazardly drilled. We identified that we had massive, thick regolith clay-hosted rare earths. So the next step was obviously to drill this out and put an exploration target in it, because we do know this continues down. So obviously all those red little triangles there you see there, they're basically where we've drilled recently, and that's where our exploration target of up to 500 million tonnes is basically being designed. So look, the good thing out here, I guess, is that we don't have any intense agriculture. We don't have to deal with many farmers. We don't have anything else to worry about out there in that respect. What we also need to know, and I guess is the one thing which Mark alluded to in the previous discussion, was that, you know, these rare earths hosted within the clays, and as Mark said, you know, they're ionic, which is a very, very cheap one. The next part is it's bound with the elements, but it's not actually in the mineral, it's colloidal. These things here are lower grade, but they are a much, much lower capex, much, much lower opex. Okay, so you've got to think of it like that, you know. So the upside, there's a lot more to come. So you'll notice here in the center, where a pointer is here, that's the Tower area. That's where we identified the initial ionic rare earths, or the clay-hosted rare earths. What we've got is we've identified a massive area up the top here, which obviously hasn't been touched yet from a drill point of view. That area itself is 150 square Ks. Again, very similar geology, very similar prospectivity there as well. So look, we've got enough. It's about what we do with it in the end. So just to give you a bit of comparatives between, say, a few of the other groups that are in the Ionic systems, IXR here, like everything is coloured on these graphs here, is the payable rare earths within their elements. Okay, so that's their basket. That's what they've got in their resources. They're the payables. So you can see ours very, very similar, okay, to these two here. Now, this company here has got a market cap of over 160 mil. The one below it's over about 60 mil. I'm going to move a bit faster because I really want to get to these slides. Basement sulfides. Okay. We've been very fortunate here. We flew some VTEM survey early in the year, and we came back with some really good VTEM and noms. We've then gone out and done some moving loop on some of the areas we could get to quite easily, and we had access. Now, we've been able to come up with some really good conductors, which we're actually ready to basically get in there and drill before the end of the year, hopefully, obviously pending heritage survey results. Now, the opportunity here is significant. When you look at where we are, how unexplored this area is, and what's happened, obviously, with Julimar and Chalice, you can start to understand that, these opportunities come once in a lifetime as well. So size does matter. It doesn't matter what they say, size does matter. So look at your EM comparisons, what we've got here. You look at Chalice's resources EM, conductor, when they first had their conductor E. Okay, now that came out at about 11,000 Siemens, basically. It was a very small conductor sitting right on the edge of the plate, whereas also very, very orientated with the magnetics, had all the other hallmarks in there too, just like we have. So what we look at, we've got two conductors, big ones. There's 10 of them really, but these are the two main ones that we're focusing on. And this is what we'll be drilling before the end of the year. So look, if you're going to get on board, it's probably time's right now, not in 6 months' time. King Tamba, quickly mention that just before I've got 14 seconds. Look, have a look at the slide. There's a lot of opportunities here. We will have a resource out before the end of the year. That's our exploration target. That's what we're looking at, and I believe we'll finished up now. Thank you.
You did well, Mark Major. I thought you did pretty well for a Victorian. You're going to play to the siren if you get through the grand final? Definitely. Okay, good. Thanks so much for coming and sharing that with us today. I'm interested to go and find out what your wife actually thought clay was. And sell. Ryan Parkin. Here's the middle stairs, sir. There you go. Are you Ryan Parkin of TikTok fame? You're not? I was looking at, there's a Ryan Parkin on TikTok. I thought I'm going to go find that and play that. All right. So you actually are more into Infinity Lithium. Is this correct?
Yeah. For the
all right. This is your day job and your side hustle. Okay. So Ryan is actually the managing director and CEO of Infinity Lithium. And Infinity is an ASX listed company who are based here in Perth. They're progressing their flagship San Jose integrated lithium extraction and conversion operation, which will sustainably produce battery-grade lithium hydroxide for the European market, which we've heard a lot about today. And you guys believe you're perfectly placed to supply that market. So let's hear more from him. Will you please welcome Ryan Parkin?
Okay, well, look, thanks for the warm welcome, Chrissy, and thanks to Jackson and the team for having us again and the opportunity to speak here today. My name is Ryan Parkin, Managing Director and CEO of Infinity Lithium Corporation, and we're progressing the fully integrated San Jose project in Spain. If you might please just note the disclaimer and cautionary statement before we step into the presentation. So Infinity Lithium is listed on the ASX under INF and also on the secondary Frankfurt Exchange under 3PM. And we're seeking to develop Europe's most technically advanced lithium chemical conversion industrial facility. And this will be located in the Extremadura region of Spain. We're primarily focused on this project to produce battery-grade chemicals up to 20,000 tonnes per annum over 26 years, to produce battery-grade lithium hydroxide to support not only the European market, but primarily in developing the lithium-ion battery value chain in Spain. We're also involved in R&D activities here in Australia under Infinity Green Tech and exploring novel and sustainable new ways for lithium chemical conversion. A quick overview of the company. We have about 415 million shares on issue and a market cap of close to 85 million Australian dollars, with more than 16 million dollars in cash at the end of the financial year. Just this week, we've announced Ramon Jimenez Serrano as a new member of the Infinity board, and this follows on from Ramon's appointment earlier this year as the new CEO of our Spanish subsidiary, Extremadura New Energies. He's a highly experienced and well-credentialed CEO in the industrial sector in Europe, and we're thrilled to have him on board with us at the Topco. We're also led technically with great experience and definitely have the runs on the board with lithium chemical conversion through our CTO, John Starink, and also through Dr. Dave Marie, who was previously with Talison. So maybe a bit of an overview in Europe, and I think we're all well aware of a lot of the geopolitical tensions in Europe at the moment, the move towards energy independence, and all of this was occurring well before COVID and well before the tensions that have arisen from the war. There's a strong demand for battery-grade lithium chemicals in Europe, as there will be globally. I'm sure we've seen earlier today projections in and around 3 million tonnes globally by 2030 for battery-grade chemicals, and that's as high as 5 million globally if you take into account the total gigafactory demand to produce battery-grade batteries to support the automotive industry. So in Europe, we're looking at more than 800,000 tonnes by 2030, and Europe's really now starting to sharpen their focus for strategic autonomy and to develop their own critical raw materials. Recently, Thierry Breton, who's the Commissioner for the Internal Market with the European Commission, has announced a plan to launch a Critical Raw Materials Act to focus on the mining, processing and recycling of these key requirements domestically. As recently as a couple of nights ago, he made a speech where he noted the enactment of the CHIPS Act, which will be focused on semiconductors. I've already allocated 90 billion euros to that last year, and also the emergence of this new Raw Materials Act to deal with the geopolitics of the supply chain globally, and more specifically, how Europe is going to be able to ring-fence their own lithium-ion battery value chain. There's quite a long quote here, and I'll let you read through that in your own time, but really to focus here on lithium and an example with a source from South America converted in China and consumed in Europe is never really going to fly, not only in terms of carbon footprint, but in particular to develop a secure and sustainable supply chain for the European Union. This was echoed again last week in Spain, where they announced a roadmap for the sustainable management of raw materials and a move towards strategic autonomy. And the San Jose project in Spain, under Infinity Lithium and our subsidiary Extremadura New Energies, is not only a raw materials project, but most importantly, retains the strategic control of those downstream lithium chemicals that will be converted on site. Reyes Morito, as the Minister of Industry, has also referred strongly to our project and lithium, sun, wind in the Extremaduran space, which is the region where we are operating. So there's been a lot of momentum since the start of this year, obviously at the higher level from the European Commission and pushing down federally. But where we're really starting to see some major change politically for our project and the ability to lodge our mining licence application has been at the regional level, where the majority of our permitting will pass through. Late last week, the Extremaduran regional government, or the Junta de Extremadura, focused on and announced a Lithium Decree Law. And ultimately, this Lithium Decree Law recognises lithium as a product of regional and public interest, or general interest. And the really important thing here is they've now mandated that any lithium developments within the region of Extremadura will have to be processed downstream to battery-grade lithium chemicals. So ultimately, the San Jose project was always designed, but now it serves as the blueprint for activity in the region of Extremadura. The government is calling for the technical presentation of the project. We've had some obstacles over the last couple of years in terms of some key permits that have been contested. However, now all levels of government are calling for the technical presentation of the project. We can see the local mayor is not opposed to this new mine. He's calling for this exploitation concession or mining license application, and we're seeing that same message from the regional government. So just to focus on the project itself, I'm sure some of you would have seen these slides before, but ultimately the San Jose project is located about 2.5 hour drive west-southwest from Madrid. It's aligned to Extremadura's vast renewable energies, highly focused on photovoltaic electricity. And Extremadura is also moving forward to really develop their green hydrogen industry, obviously using those vast renewable energy resources to produce a green and alternative fuel to Russian gas. We are seeking to develop a large-scale integrated lithium chemical processing facility on site while utilising a lithium-bearing mica ore, which is the second largest hard rock lithium resource in Europe. We've developed a proven sustainable process flow sheet using a sulfate in the kiln. And ultimately, this is giving us a very different tailings profile. So through the support through EIT and Energy and European funds, they've fully funded our test work program that has been completed with Dorfner plan, and we now start to move into upscaled activities. We're building generational opportunities for the locality of Cáceres, and really where we've seen these major changes for our project have been along the social licence, the change in attitude towards the local community after moving to underground extraction, and also developing lithium-ion battery training and development opportunities along the likes of EIT, Energy and other major players in the sector. So our resource was defined in 2017, 111 million tonnes, which is about 1.6 million tonnes lithium carbonate equivalent. This is a large homogeneous ore body. This is a tin mine, an underground tin mine from the 1960s. There were various drilling campaigns undertaken in the late 80s and early 90s. And that same regional government that passed this Lithium Decree Law put this project out to tender in 2016. So we've had various invigorations of the project, from a lithium carbonate project now to an underground project in line with the demands of the local community to win that all-important social licence and move forward in the permitting process. So this is just a quick visual on what the lithium hydroxide conversion plant would look like. We'll be utilising a porthole and a 1,500 metre decline. So there are various obvious advantages to moving underground in terms of noise and dust, and also from our tailings being able to return now more than 60% of that back underground. The actual project itself, it's very important from a local perspective to recognise that this is primarily an industrial project with an on-site feedstock. So of the 532 million, including contingencies, more than 85% of that is aligned to the beneficiation plant and also to that downstream lithium chemical conversion process. Our world-class team, led by John and by Dave, have been guiding Dorfner plan in Germany with this novel and sustainable process. And we're also in the process now of lodging our provisional patents to protect this technology. The test work has confirmed the production of battery-grade lithium hydroxide and lithium carbonate that gives us optionality as we move forward to align the right strategic partner, and at the end of the day, their end needs. However, in the European market, it appears that the vast majority of those partners will be aligned to battery-grade lithium hydroxide. We have an existing non-binding offtake in place with LG Energy Solutions, obviously one of the global giants in the space, but we're also engaged in a number of other discussions with strategic partners as Spain seeks to develop its own fully integrated lithium-ion battery value chain from cradle to grave, from the resource through to the production of batteries. So our administrative process here sees us addressing a matter that is currently before the courts, before the contentious administrative court of Cáceres, where our investigation permit Valdeflores is due over the coming months to reach its conclusion. And ultimately, we believe we have a very strong case for that permit to be re-granted. If that is the case, we can move forward to lodge our mining licence application, exploitation concession as it's referred, with that investigation permit and an accompanying investigation permit that we have for the industrial area. However, under Spanish mining law, we've already undertaken our drilling activity. We have a defined resource. we have rational use for this that is considered valuable, as evidenced again by that decree. So we're able, through a subsequent exploration permit that we hold as next right in succession, to apply for that permit, and upon granting, submit what is called a direct exploitation concession. So we remain committed to the most available route to lodge this application. However, under any scenario, the legislation under Spanish mining law provides us with those avenues. We continue to work closely with the local community, with business groups and associations such as Loaba and CAREX, the CEC Business Circle, to align industrial activities and employment opportunities from the project, but also to attract other industry to accompany the project, by way of example, photovoltaic, green hydrogen and the like. We're working with the Chamber of Commerce there, represented by Kamara. We're working with EIT Energy to develop innovative training and development programs for a community that suffers from high levels of unemployment and rapid depopulation issues with their youth. So really, these sort of initiatives are really putting Caceres on the map to develop a lithium-ion battery and renewable energies training centre. Just quickly to touch on some of our environmental credentials. I mean, we're using the underground extraction of this lithium-bearing mica, so there are natural advantages there in terms of noise, visual impact from our previously presented open pit about this time last year. So we've really responded to the local community to address their concerns. We're able then to return a lot of that waste underground, and due to our novel, innovative process, our tailings are relatively benign. So what is on the surface, we're able to continually rehabilitate and replant the site. Our process flow sheet allows for the constant recycling of these reagents. So having a full LCA in place is obviously advantageous in the European market, not only for the community and the environment, but also against the backdrop of a battery passport, which is going to govern the carbon footprint for all batteries that will be consumed in e-mobility in Europe. We're working with ThyssenKrupp to utilise green hydrogen to power our kiln, our largest emitting component. And also the proximity of our feedstock to our converter, it's on site. We're not moving low-grade material halfway around the world. We're able to minimise the economic impact of that process, and also our customers will be in close proximity in Europe. Our project economics, again, they've been in the market for quite some time, but under some relatively conservative pricing assumptions at $17,000 a tonne for lithium hydroxide, we see a very robust NPV of more than $810 million US. The current spot price is more than $75,000 a tonne. So, it's widely accepted there's going to be robust pricing conditions for some time to come. And over the longer term, as we come into production over the first decade, we definitely expect to see pricing in the mid-20s. So really just to try wrap this up within the 15 minutes, Europe has a number of challenges ahead of them to secure their raw materials, but most importantly, their precursor material. They've invested really heavily in lithium-ion battery plants. There's more than 1,000 gigawatt hours in the pipeline, and they're going to need the resources and the downstream conversion capacity to be able to fulfill those needs. San Jose has an essential role to play in that, not only for Europe, but really for Spain, and particularly Extremadura, that now has the opportunity to do the cradle to grave and develop their own lithium-ion battery value chain. So thank you for the opportunity to present here today. And if you have any questions, please come see us at our booth.
Thanks so much, Ryan. And we are running beautifully for time as our next presenter leaps up here onto stage to join us again. We've had him as a bit of a regular at our RIU conferences and always good fun. Simon Kidston is his name. He is the non-executive director of Lithium Plus Minerals. His background is in investment banking. He's got more than 30 years global experience with groups such as Macquarie Bank and HSBC. He's also founder and the non-executive director of GenX Power, which is an ASX-listed renewable energy company with more than $1 billion worth of assets. Would you please make him welcome?
Thanks very much, Chrissy, and great to be here today. Lithium Plus is a very simple story. It's pure play, high impact exploration. And no one's going to die wondering about our exploration program. We are aggressively drilling out our tenements to the point where we'll do 4,000 metres a month for the next 3 months. So we're going to have a lot of news flow about our exploration success. This is a strategic land package located just outside of Darwin, literally 45 minutes from Darwin. The tenement package was acquired back in 2018, early 2018. That's important because our neighbour, Core Lithium, now about to commence production on their brand new lithium mine, had a market cap of $20 million and was unknown in the capital markets and the investment community. At that time, our founder, our chairman, Dr. Ben Guo, acquired these tenements and commenced the early stage exploration. So the point now is that we've got fantastic tenements surrounding an operating mine with the continuity of mineralization onto our properties. So the focus of the business is on this Bino lithium field surrounding Core Lithium's mine just outside of Darwin. So it's a very, very exciting tenement package, which we're getting into aggressively right now. In terms of the capital structure, we listed on the ASX in May of this year. The share structure is very, very tight. 48% of the shares in issue are escrowed for 2 years or another 18 months from now. So that means any news flow, any discovery we do have and announce to the market should mean the share price reacts to that because it's very, very tight capital structure. In addition to the founders and directors who have massive skin in the game, we've got a very significant strategic investor. CATL, the largest battery manufacturer in the world, invested money at the IPO and now have 9% of the company. That's a very, very important relationship. And I would imagine that they'd be very keen to secure offtake rights. Clearly, we won't have those discussions now, but when we've defined our ore body, we've got a very clear route to commercialize our discoveries with the biggest battery manufacturer globally. So it's a very tight share structure. We've got a very strong cornerstone investor. The business is well capitalized. We've got $9 million of cash. We don't need to rush back to the market. We can prosecute an aggressive drilling campaign and demonstrate the results for our shareholders. And finally, I believe we've got a very, very modest EV, some $50 million with a market cap of $60 million. It's all about the drilling, and we're going to be super active. Essentially, we're going to drill at least 10,000 meters of RC drilling. That's pretty much a hole a day for the next 3 months, and we'll back that up with some diamond drilling. We've already had some good success with our initial drilling, and I believe we'll be able to replicate that over the balance of this year. I guess our discovery hole, which was actually drilled by our vendor, was 12 meters at 1.4% lithium. Interestingly, those grades, those widths are consistent with what's been drilled and discovered next door by our neighbour. And essentially, our neighbour is drilling right to our boundary, seeking to extend their mine life with additional tonnage. And luckily for us, it looks like those pegmatite dikes well and truly extend onto our side of the fence. So it's a very, very exciting time to be exploring for lithium in that context. We've got some happy snaps here of our excited exploration team. Many of these guys, many of the drillers and exploration manager worked for Core, our neighbour. And I guess what they're seeing on our side of the fence is consistent with what they've seen before. Good mineralization of lithium pegmatite. So I guess to really cut to the chase, what are the key highlights of this business? Well, firstly, it's all about location. We're 45 minutes from Darwin. And what that means is that we've got phenomenal access to existing infrastructure, power, port, sealed roads right on our doorstep. Obviously, that means any mine development is going to have the benefit of that infrastructure, which leads to low capital intensity, a key driver for our shareholders. Secondly, and possibly most importantly, we've got phenomenal geological prospectivity. The drilling that we've done to date is consistent with Core. They've got 18 million tonnes, I think, grading 1.5. What we've seen so far looks very similar to what they've got. A series of deposits a couple of million tonnes each, adding up to that 18 million tonnes. We hope to replicate that on our side of the boundaries. We'll know very soon the extent of our mineralisation with our very, very active drilling campaign, which is going to translate to very, very active news flow. So we'll have, I would imagine, announcements to the market every month or so between now and the end of the year. I mentioned our strategic shareholder, CATL. They're the largest battery manufacturer globally. We've got a very strong relationship with them at the chairman level, and that bodes well in terms of commercialising and potentially funding mine developments. And finally, I like to think our board and management team have the runs on the board, the proven track record to deliver for our shareholders. Okay, if you have a look at this map on the right-hand side, it depicts Lithium Plus's tenements in pink and Core Lithium in orange. And you can see that we surround the operating mine that is owned by Core. It is a strategic land package. In total, we're looking at 1,700 square kilometres. And our focus is going to be very much on this area, the binode lithium pegmatite field. The exploration to date, the soil sampling, the ground penetrating radar means we've got lots of walk-up drilling targets. So we're going to be super active drilling those targets between now and the end of the year. Our discovery hole, 12 metres at 1.4, has been followed up with our first published exploration result. We intersected 43 metres of mineralised pegmatite. That core is currently being assayed, and I'd expect to announce the results of that in the next couple of weeks. But certainly we're hopeful, and the team is very hopeful that that continuity with is going to continue down deeper. In addition to, I guess, what we've discovered, we've also identified a series of parallel dikes, lithium bearing, that we'll be targeting as part of this current exploration program. I'm no geologist, I'm the commercial guy, but we've got a very strong technical team. But even I can see in these two images here, essentially you've got outcropping pegmatite at surface. At surface, it's been weathered and not particularly mineralized. But when you correlate the outcropping pegmatite with the ground penetrating radar and the anomalies, you can see exactly where you need to drill. So essentially the team identifies the outcrop, they drill below it. Once they get below 40, 50 meters, which is the weathered zone, once they get into the fresh rock, that's when we hit the mineralized zone. So it's a very, very simple model. It's worked for Core, and we're following the same recipe in terms of decoding and unlocking the exploration package that we've got in front of us. This is another one of our tenements. I won't go through too many of these. The features are the same, essentially outcropping pegmatite, ground penetrating radar, confirming the anomalies. We'll drill each of those. And I would hope that we would have multiple deposits, which will add up to something interesting over time. This map on the right-hand side shows our tenement in turquoise, Core Lithium's tenement in orange, what's that? Orange? No, that's pink. I'm slightly colorblind. Essentially, the exploration they've had on their side identifies a trend which is backed up by the ground penetrating radar and the soil sampling we've got on our side. So that's one of our hot prospects. We'll be drilling that in the next month. So we'll have more to say about that before the end of the year. If I'm looking at how this plays out into our exploration program, it's simple. It's actively drilling continuously for the next 3 months. We'll utilize essentially December through March to interpret that information. And the strategy is to publish our maiden JORC resource by March next year. That, I think, will be a major milestone. It will be a key stake in the ground in terms of how this company will commercialize our deposits. And from that point, we'll be able to commence scoping studies and feasibility studies. But March next year will be a major milestone, and that will follow this year's aggressive exploration program. Just a few words on our second largest shareholder, CATL or CATL from China. They're the largest battery manufacturer globally. They account for 32% of the battery production, 32% market share globally. So the clear dominant player in the market. We're delighted that they've partnered with us. Clearly, they're looking to get exposure to offtake. Tactically, we've not given those rights today. We'll wait until we've defined our resources and no doubt see if we can extract some funding of the mine development in recognition for those offtake rights. So those discussions will happen in due course, but it's a phenomenal relationship. In fact, our chairman, Dr. Bin Guo, has had a very, very long decade-plus relationship with their chairman. Their chairman is one of the top 100 richest people globally, and it's chairman-to-chairman type relationship, which bodes well in terms of finalising the detail behind any of those arrangements. So just on our board, it's a board with a proven track record, led by Dr. Bin Guo. He's our founder. Bin's travelled the world studying and analysing deposits globally with a particular focus on pegmatites. He did his PhD at Macquarie University in Sydney. He's worked for many years at SRK looking at those projects globally. He was a very early investor in AVZ, a company with a very significant lithium deposit in Africa, and he picked up these tenements near Darwin at a time when the sector was unloved. So he got these phenomenal tenements by utilising his deep network and understanding of good ore bodies. My background's commercial, former banker, currently a non-executive director of Genex Power, a company which is currently under a takeover bid with an enterprise value of $1.2 billion. I was the founder of that business. Jason Burton, he's a geologist. In fact, he studied his PhD with Bin some 20 years ago. There's a long-standing relationship there. And then finally, George Su, Sydney-based, very strong, smart, commercial head on his shoulders, deep connections into China. So that's our board. It's very tight. And then our management team and exploration team, very experienced, many from SRK, many with experience working for Core next door. I won't labour the point here. I think everyone's in this room because they understand the huge transition underway in the economy as we transition to EVs and the electrification. That's good for all of our investors here and all the companies presenting. So to wrap up, I guess what we have is an outstanding location. It's outstanding because of its geological prospectivity. It's outstanding because of its proximity to existing infrastructure. We've got a super active exploration program. We're fully funded to execute on our strategy. There's going to be continuous news flow into our identified targets all of this year. Our cornerstone investor, CATL, brings a very interesting angle in terms of funding and commercializing any deposits we make. And then finally, we've got a board and management team with runs on the board and a proven track record. So thank you very much. Thanks, Chrissy.
To Kidston, thank you so much. You go back to Queensland now? Good lad. Okay. All right. Do you remember at the start of this session, I said, keep an ear out for a little announcement, which may be made by one of our presenters? We've only got one presenter left in this session, and it is Australian Strategic Materials, ASM is the code. It's an emerging processor and producer of strategic materials for the high-tech and sustainable energy industries. Its cornerstone rare earths and critical minerals project is in Dubbo over in New South Wales. Its flagship high-tech metals plant, and I notice a small shake to the hand as she puts the water to her mouth there. She's very excited, is in Ochang, South Korea. Here to tell us more about this vertically integrated business is ASM CEO with a big smile on her face, Ms. Rowena Smith. Please make her welcome.
Good afternoon, everyone. It is a pleasure to be here today, and I am really looking forward to, obviously excited, but I am really looking forward to telling you about the business that we're building at Australian Strategic Materials. This is our disclaimer, which I encourage you to read through later. And I begin by acknowledging the traditional custodians of country throughout Australia and their connections to land, sea and community. In particular, I acknowledge the Whadjuk people of the Noongar Nation on whose land we meet today. I pay my respect to their elders, past, present and emerging, and extend that respect to all Aboriginal and Torres Strait Islander peoples. ASM. We listed on the ASX in July of 2020, following a demerger from Alkane Resources. As I said, I'm the Chief Executive Officer and I've been in role now for nearly 2 months. Before this, I was ASM's Chief Operating Officer, joining the company in July of last year. Supporting me, I have a highly credentialed board of directors led by our chair, Ian Gandel, and a skilled and dedicated executive management team. Together with our teams across Australia and Korea, we are building a business to resource the technologies and industries driving the 21st century. At ASM, we want to be part of the solution to the challenges of climate change and contribute to the technologies that can improve our quality of life. Now, being at the New World Metals Forum, I know I'm speaking to the converted here when I tell you about the extraordinary growth in demand, both seen and predicted, for strategic materials like the rare oxides shown in these graphs. And we've seen a lot of similar data this morning. The neodymium, praseodymium, dysprosium and terbium are all examples of materials in our Dubbo resource that are vital inputs for a vast array of strategic and industrial applications worldwide. These growth industries are driving the economies of the future, and governments around the world are recognising their strategic importance for economic security. Hence, we're seeing a race to secure strategic stockpiles among governments worldwide. And of course, it's not just demand driving the race. So again, we've seen various looks at this kind of data through the day, but global supply chains for these strategic materials are heavily monopolised. And if we look at this example for rare earths, if you just note all of that blue area across all stages of the supply chain, it shows how heavily monopolised it is by one nation. This causes significant risk. And it's clear that alternative options like ASM are urgently needed. ASM offers a vertically integrated solution that begins with our cornerstone rare earths and critical minerals Dubbo project in New South Wales and extends to our flagship high-tech metals plant in Ochang in South Korea. Combined, these operations can provide a reliable and secure source of strategic materials for governments and industry. So let's begin with the Dubbo project. ASM's Dubbo project is founded on a world-class polymetallic resource of rare earths and critical minerals, including neodymium, praseodymium, zirconium, niobium, and hafnium. The polymetallic resource was actually discovered some years ago, and I'm sure many of you have heard much about it over time, but it's taken the surge in the demand for these resources and advances in extraction and processing technology to catch up with the vision for this project. For over a decade, ASM has been working with ANSTO to develop a proven flow sheet that optimises oxide recovery and will allow us to process on-site to produce metal oxide products. With the key approvals in place and a proven flow sheet, this is not just a construction-ready project, it's also ready at the right time and in the right place. In December of 21, we completed an optimisation study for the Dubbo project, which confirmed a strong go-forward case. The study confirmed the project has a strong technical foundation and robust economics. The polymetallic nature of the Dubbo resource offers a diversified product suite, which de-risks exposure to single commodity price variations. The study showed that Dubbo could deliver an excellent outcome for our shareholders, with a forecast pre-tax internal rate of return of 23.5%, equating to a post-tax internal rate of return of 20.1%. Based on existing ore reserves, the project is forecast to have a 20-year life of mine at 1 million tonne per annum feed rate. This could be extended up to another 50 years based on measured and inferred mineral resources and the necessary approvals being granted. Now, we're not the only ones that are excited by the Dubbo project's potential, as this lovely photo shows. In June of this year, Hyundai Engineering Corporation joined us on our development journey. ASM awarded Hyundai Engineering a contract to provide engineering, procurement and construction definition work, what we call EPCD, as summarised on this slide. This work allows for additional services beyond feed so that Hyundai Engineering can produce an open book cost estimate, which will form the basis of an EPC offer to deliver the Dubbo project. Having a company of the calibre of Hyundai Engineering joining us, I believe, highlights the significance of this project, not just for Australia, but internationally. In time, ASM will process the materials produced at the Dubbo project in our high-tech metals plant in Korea. Our Korean metals plant is in the Ochung Foreign Investment Zone, about 115 kilometres south of Seoul. The plant was officially opened in May, which was quite a feat, as we went from concept to opening in just over 1 year, all while contending with the disruptions and restrictions that resulted from COVID. We're currently in phase 1 commissioning. Our initial focus is on neodymium metals and neodymium iron boron alloys for the permanent magnet market, which, as we've heard this morning, are used in electric vehicles, wind turbines, and other advanced technologies. So as Chrissy foreshadowed at the beginning, in breaking news, I'm really excited to be telling you that we announced earlier today our first sale of neodymium praseodymium metal from the plant. We've signed a binding sales agreement this morning with Kosdaq-listed company NS World for sale and delivery of 10 tonnes of neodymium praseodymium ingot from September through December of this year. And as you can see in this picture, we are very happy to have reached this milestone. I'm sure you can see our smiles even through the COVID masks. Joining me in the photo is Cho Depwinim, who's our representative director and leads our operations team there in Korea. And I can tell you that team have worked incredibly hard to achieve this result. And we're really looking forward to the first delivery in the next couple of weeks. ASM's Korean metals plant represents the first of the high purity metal plants we intend to develop as part of our long-term vision for the business. Supported by oxides from the Dubbo project, ASM is aiming to have other plants strategically located around the world in areas close to the end users. In this way, we'll be able to work with our customers to develop products to suit their specifications. And as we progress this vision across all our operations, ASM's ethos is to be an ethical and sustainable company. We seek to positively contribute to the efforts needed to solve global challenges such as climate change and to leave a legacy that delivers enduring benefits to the communities and regions where we operate. This means we're targeting operational net zero and intend to use renewable energy where possible. The Dubbo project also has initiatives in place to protect biodiversity. Large areas have been designated for the restoration and maintenance of native habitats, especially for threatened and endangered species such as the pink-tailed worm lizard pictured. We have a wholly owned subsidiary, the Tungai Pastoral Company, which manages these biodiversity offsets and conducts farming operations on the agricultural land around the Dubbo site. This year, ASM and Tungai Pastoral Company partnered with the Macquarie Anglican Grammar School to deliver their Macquarie Agricultural Pathways program. This gives selected Year 7 students the opportunity to develop skills necessary for future employment or studies in agriculture. In fact, I attended the launch of this program on only my second day as CEO, and it was such a delight meeting the students who'd been chosen for that program and just seeing their enthusiasm for this very practical, real-life approach to learning. As I said at the start, ASM acknowledges the traditional custodians of country throughout Australia. And when we opened our Korean metals plant, we wanted to build a cultural connection between Dubbo and Korea by inviting a Wiradjuri elder from Dubbo to join us and conduct a smoking ceremony for our Korean guests. It was quite tricky sourcing the eucalypt leaves, I can tell you. But it was a very moving sharing of ancient culture, building the bond and connections between Korea, Australia, and Wiradjuri countries. So in conclusion, this is a very exciting and crucial time, both for ASM and the strategic materials market. And with ASM's vertically integrated business model, from our Dubbo project in New South Wales to our Korean metals plant in Otang province, we aim to deliver a reliable and secure supply of strategic materials to governments eager to shore up their natural stockpiles and to industries solving the challenges of this century. The time truly is now for ASM. And all our team are keen and ready to deliver our potential. So thank you very much for listening to me today. I appreciate I'm the last speaker between you and lunch, but I'm really looking forward to speaking with anyone who wants to discuss this with me more over lunch or through the afternoon. Thanks very much.
Well done. Congratulations. And they're up 4.84% since the announcement. So congratulations to you. Hey, but have you been to any of our other conferences and seen ResApp or Brian Liebman present at all? ResApp? So the takeover from Pfizer was approved in the last 24 hours. They're up 197% since the start of the year. That is massive. And every time I missed getting on board in the last 3 months after talking to them, I've kicked myself. But we've got some absolute fantastic investment opportunities. If you stick with us long enough, you never know what you're going to find. Go out and enjoy lunch. And we'll be back for session 3 and 4 in approximately 45 minutes. Thank you.